Hi, friends. Today I'm going to talk to you about what amount of depth of focus would be beneficial to the patient without taking anything away from the image quality, right? And this I'm actually talking in the context of EDOF IULs and enhanced monofocal IULs. Today, this is a world plethora of lenses out there which actually, you know, promises the patient with an excellent intermediate vision, and some may be giving a bit of near vision also. But at what cost? What would be a right balance between the image quality and the depth of focus that the patient may get, right? And as we know that the depth of focus and the image quality, there is a blur circle over here, and the depth of focus that you get from longitudinal spherical aberration are actually juxtaposed. They are antagonistic to each other. So the more the depth of focus you give to your patient, the less would be the image quality, right? The less the depth of focus you give to the patient, that is the marginal and the paraaxial rays of light coming to one focal point over here, the blur circle will be less, the image quality will be more, but the depth of focus will be less, right? So this is something that is fundamental in optics, fundamental in physics. Now, having understood it, let us try to understand actually what would be the right balance between providing an excellent depth of focus to the patient in terms of intermediate vision and some amount of near vision, but at the same time, there is no remarkable drop in the image quality, as that is also important, especially in mesopic conditions. And to that regard, I found this study very interesting, and they worked with uh, real patients, and they employed the adaptive optics. And now the adaptive optics is actually a vision simulator, so you can actually artificially induce spherical aberration in the patient, and record the image quality as well as depth of focus over here. So in this study, actually what they did with adaptive optics, in terms of total ocular spherical aberration, um, they have five sets of patients, right? The patients, the first patients group had no spherical aberration, right? In the second, they induced minus zero point zero 0.07, that is negative spherical aberration. The third group, minus 0.15, that is again negative spherical aberration of minus 0.15. The fourth group, a negative spherical aberration of minus 0.23, and the last group was induced with a negative spherical aberration of minus zero point 0.30, and they wanted to study the depth of focus and the relationship with the image quality, right? And this table is quite interesting over here. So patients who had no spherical aberration, right? The patients who had no spherical aberration, you can see the defocus. So they measured the visual acuity in terms of the defocus, that is the FIR vision over here, zero, that they did not induce in defocus. And then they also measured at 66 centimeters, and also they measured at the near point at around 33 centimeters. And they all did it, and they did this experimentations with 4.5 millimeter pupil diameter. And what they found over here is that when you are inducing a spherical aberration of minus zero point zero 0.07 to minus 0.15, then the distance visual acuity actually drops, but the near and the intermediate improves at not a major cost to the distance visual acuity. But if you go beyond minus 0.15 of microns of negative spherical aberration, add minus 0.15 of micron of negative spherical aberration, more than that, then you have near and intermediate vision improvement at the cost of the distance. So that's basically what this study actually points out in this table. So if you look over here, When you don't add any spherical aberration, the near vision is around 1.31 of logmar. The intermediate is around 0.54 of logmar, and the far is around 0.14 of logmar, right? So this is without adding any spherical aberration. And I can show you a chart which basically in my blog quickguide.org, you will find this chart over here of the conversion between the logmar to the Snell's visual acuity right over here. So a 0 logmar means 6 by 6 of vision and 20 by 20, right? Zero point 0.1 logmar corresponds to around 6 by 7.5 and 20 by 25, and so on and so forth. You have the zero point 0.2 logmar as 20 by 32, 0.3 logmar as 20 by 40, right? So going back to the study over here, when patients were induced with around minus 0.07 of negative spherical aberration, the near improved, the intermediate improved. So the intermediate improved from 0.54 to 0.39, right? And that will actually correspond to uh, to something around over here to around 20 by 40. So the intermediate improved to around 20 by 40, but there was a one line drop in the far focus in the distance visual acuity. So when there was no spherical aberration with this group of patients, they recorded around 0.14 of logmar, which is around around 6 by 7.5, around 20 by 25 of vision. But that vision actually dropped by one line when you induced a negative spherical aberration of minus zero point 0.7, minus 0.07, excuse me. And the near actually improved, the intermediate also improved to around 20 by 40. Now if you when they induced around minus 0.15 of negative spherical aberration, the near further improved, the intermediate also improved to n 0.3, which is around 20 by 32 of vision. But the far focus actually dropped. The distance visual acuity now dropped by another one line, right? So when the distance visual acuity dropped by two lines, actually considering that, if you had added no spherical aberration, the vision was around, the far focus was around 0.14. So from there, it dropped to around two lines over here. So this may be an interesting, study for those actually who are interested to know in this world of enhanced monofocal IOLs, monofocal plus IOLs, EDOF IOLs, what is the maximum spherical aberration that you can actually add without bringing in a significant drop in the visual acuity for the far focus or image quality for the far focus, right? I hope you found this interesting. Keep following my blog quickguide.org and subscribe to my channel for more interesting videos in future.